In this video, I'm going to show you how to use the T.test function to perform a left-tailed test about a single population mean. To do this, you're going to need to have a set of hypotheses. So in this case, I have a null hypothesis that says a population mean is equal to 3 versus an alternative hypothesis that says this population mean is something less than 3. And so then I'd want to also decide upon a significance level or a probability of a type 1 error. So we'll use 0.05 in this particular case. And based upon that, I can set up a rule for rejecting that null hypothesis. The rule would say that I'll reject if my p-value that gets calculated is less than that significance level, less than that alpha value. Now to perform this test for real, I'd have to collect my data in a very particular way. I'd want to make sure I have an independent sample or a simple random sample. And then I'd want to check that this data either looks kind of normal or it's not super skewed and doesn't really have any outliers in it. So this data that I just had R make up for us is right here. The way I'd actually check that is I'd go ahead and load it up. And I can really only check the second condition here because this really isn't a random sample. But I can make some histograms and I'd look at them and I'd say, well, they look relatively normal in terms of my histogram there. It does have a little bit of the thing there, but it's only 20 data values, so it's not too crazy. If I look over here at my box plot, I can see it's not super skewed. Doesn't look like there's any outliers in it. So if this indeed was true data and it was a simple random sample where I had an independent sample of these data values, I'd be able to say I trust this analysis here. And so the way I'd actually do my computations is I'd pull out my T.test function and I'd have to tell it where my data is. So in this case, it's this vector samp. Then I'd have to tell it my alternative. And my alternative in this case comes from my alternative hypothesis. It's a less than there. So I'd type in less. And then I'd have to tell it my hypothesized value, this value for mu, the mean. And we're hypothesizing that it's 3 in both of these here. So I'll just say mu equals 3. And then we'll ignore the rest of the arguments here because they're meant for other types of tests. And we'll just go ahead and run this guy. And what we'll get back is a one sample t-test. And then we can check down here and see that it's using the right alternative, that our true mean is less than the number 3. And then we'll get our test statistics and our degrees of freedom here. Our one test statistic is negative 3.2024. It used a degrees of freedom of 19. And then we'll see what we wanted here for this particular way we're doing this. So we'll look at our p-value, and we're going to check, is 0.002344, is that indeed smaller than 0.05? And that is actually the case. So for this data, if this actually was a real data set, we would actually have a reason to believe that our null hypothesis is wrong and that the alternative is actually true, that the mean is actually something less than 3. So we decide to reject this null hypothesis. So that's how you can go about using the T.test to perform the computations for a left-tailed test about a single population mean.